Thevenin's Norton's, then your superposition theorem and maximum power transfer. So three of those we have done. Okay. The last one is your maximum power transfer theorem. Okay. One of the most important topic. Okay. Most important theorem. In practical cases also you require this maximum theorem. That means what is the basic idea? Okay. Again, you are using some kind of appliance in your home. Okay. So what you require? That means it should give you the maximum efficiency at minimum power consumption. You see the star, okay, star level. If it is a 1 star, it consumes maximum amount of power. Okay, it's inefficient. If it's a 5 star, then more energy saving will be there. So how much power is being consumed? You are transferring some power, okay, through the source or whatever source is coming to your home, but that power should be consumed efficiently by an appliance. Okay, so what are its conditions? We have already told you any like appliance that you can denote using a simple resistance, that is a load, it is consuming power. But in practical cases, it will have some capacitive element, it will have some inductive element. Like any motor thing, it will have some kind of a inductive element because magnetic fields are there. So energy will be stored in the magnetic field. It will, those energy you cannot use. Okay, so they will lost. So actually, how much power you can consume? Okay, how much is being delivered and how much you can consume? That this theorem gives an idea about that. If you go into the AC circuit, it will be more relevant. But for DC also, using simple example, we will see like what is the condition on the load resistance so that maximum power is delivered. Okay. Now you say that, okay, if I am buying a AC or if I am buying a fan, how can I decide its load resistance? There are ways. There are ways. Impedance matching and everything are there. We'll go in, means in your next semesters you will do that. Consider this simple example first. That means there is a load. There is some voltage V. Okay. There is a, again, I have told you that ideal voltage source has zero resistance. So we were replacing this with a short circuit. But in practical cases, it will have some internal resistance. RS, the source resistance. This is, let us say, V. Now, at the end of Thevenin's theorem, you have reached this. Means there can be a many complex network here. But we are not interested in that. Using Thevenin's, we have the knowledge of Thevenin's theorem. That means any complex circuit we can represent like this. What we are interested in, that we have this load RL. We have this load RL. Okay. So what should be the value of RL? The question is, what value of RL will result in max power transfer. Okay. Now power, how to calculate that? First you have to know how to define power. Okay, then only we can maximize and minimize those things we can do. So power we have already seen. Power is nothing but voltage multiplied by current, or V multiplied by I. So what is the voltage across these, across the this load, and what is the current flowing through it? If you know that, you will be able to find out what is the power. So let us first find out what is the current flowing through this circuit. I. I is nothing but voltage that you are applying, and these two resistances are in series. RS plus RL. Okay. RS plus RL. Now, to calculate power, VI. So this V you can also write as V equal to IR. This V using Ohm's law, you can write I multiplied by R. Again, it is the R equivalent. Okay. Or this is RL. That means we are trying to find out what is this V, what is this V, and what is the current flowing through this I. Okay. So V you can write as I multiplied by RL, I multiplied by RL, multiplied by this I. So you can write as I square RL. You can write it as I square RL. I you have found out. This we can put here. That means V divided by RS plus RL whole square multiplied by RL. Okay. So this is the power. This is the power that will be consumed by this load RL. Now our aim here is to find out for what value of RL maximum power will be delivered. So maximize and minimize and you have already done. Okay. So this power now is a function of RL. Okay. To maximize this, what we have to do? We have to find out the you differentiate this. You can differentiate this power with respect to RL and you can equate that equal to 0. Whatever value of RL you will get, that can be either maximum or minimum. Okay, then you have to do the double derivative test. Okay. So the first thing you have to do is to differentiate this power. You have power as a function of RL. You have found this. That is V square multiplied by RL divided by RL plus RL, RS plus RL whole square. That you have found out. So this you have to differentiate with respect to RL. That means okay. If you differentiate this, differentiation, you know, I'm not explaining that. I'm just writing the answer equate to 0. So if you want to equate this to equal to 0, then if the numerator, this term becomes equal to 0, the whole thing will be equal to 0. Okay. So V, it means okay. So if you do this thing, that means if you make the numerator equal to 0, yes. If you make the numerator is equal to 0, that is RL plus RL whole square minus twice RL, RS plus RL, that if you make equal to 0, then if you just simplify this, what you will get? This will be equal to 0 when your RL will be equal to RS. Okay. That means when the load resistance become equal to the source resistance, then maximum power will be delivered. Now, how much power will be delivered? So your power that you calculate, it was I square R or V square RL divided by RS plus RL whole square. Okay. So now RS has become equal to RL. Okay. So V square, you can keep it RL Okay. So this will be your maximum power that will be delivered. Okay. This will be the maximum power that is delivered. Yeah. Now, based on this, we'll solve some examples. Let us first see one example. Let us first start with one example, and it will require other concepts also. So Thevenins and Nortons, everything will be required here, and some other concepts will be required. We will solve that one by one. So let us say there is a 15 ohm resistance. You can just also draw in your using pen and paper, just draw it and try to see that how you will solve. There is this 5 ohm resistance. There is this 10 ohm resistance, 15 ohm resistance. This is your load resistance. You don't know what will be the load resistance value. So the question will be find out the load resistance for which maximum power will be delivered. So you know RL will should be equal to RS, but you don't know the RS here also. So first you have to find out what will be the RS. Okay. So here the question is find out RL so that maximum power will be delivered. So from a basic understanding of maximum power transfer theorem, RL should be equal to the internal resistance RS of the source. But you don't know what is RS. Here there are this 100-volt source and there are many other things. So this circuit using Thevenins or Nortons, what you have to represent with using, if you apply Thevenins, that means after applying Thevenin's theorem, you have to represent this circuit like this. VTH, in series there will be your RTH, and then you have to connect the load here, RL. So if you can do that from this circuit, if you can come here, then you know, then if RL will be equal to RTH for maximum power transfer. Okay, but from this circuit you have to reach here. So what was the first step? What was the first step here? Apply the Thevenin's theorem. Step 1, remove the load. The load is here. This resistance with the arrow sign on it, that means a variable load. Okay, at what load resistance you will get maximum power. That means you have if you find RTH, then if you vary this RL and fix it at RTH, then you will get maximum power, okay, across this RL. So that's why it's variable load, okay, so that you can adjust the load so that it becomes equal to RTH. Then the first step, you have to make it open circuit. The load should be removed. Other things remain same. Okay. Now, here will be required one more topic. That means if you see this part, okay, if you see this 5 and 10 are in series. So you can replace this, and with a equivalent resistance. That means it was 5 and 10. That means the sum will be 15. So you can replace these two resistances with this 15 ohm resistance value. That you can do. Again, here, if you see, this 18 and 9 are in series. So you can add them up. Okay. You can add them up and replace this with 18 plus 9, that is 27. Okay. The next step will be to find out what is the voltage across this. That means that will be your VTH. You can identify the number of mesh, number of loops that you can identify. But to further simplify, you need one transformation. Okay. This one is a delta circuit. Okay. To star. And if we study this thing, we will also study star to delta. In some circuit, if you transform from star to delta, it will be easier. In this circuit, if you transform from this, that means instead of this, okay. So how this delta circuit looks like? It looks like this. Whenever in a circuit, you will get this type of a 41.46. Someone is Arin is saying, but here the answer is like 70.88 or 41.46. I am talking about VTH. Okay, Pratik. We will discuss that later. I am giving you attendance only. Praveen Raj, I am not giving the attendance. I am giving to Pratik. Pratik Raj. Okay. Arin, if you are giving the answer for VTH, here the answer that I have, the answer is 70.88 volt. RTH is 23.92, and maximum power that will be transferred is 52.51. So you can recheck that. Yeah. So for others, let us first study how to transform from delta to star. It will be very easy. It will be very important for your future also. In like AC circuits and everything, this will be important. Okay. So let us consider this as RA, this as RB, this as RC. This is your node 1, this is your node 2, this is your node 3. You can just see this node 1, you can consider this point, this node 2, you can consider this point. This node 3, you can consider this point. Okay. Now, it will be equivalent to a star network where the same nodes, the numbering of the nodes, the order in which you are doing the numbering, that will be important. Okay, this is second, this is the first, and this is the third. Now it will be star connection. That means let us consider this as R1, consider this as R2, consider this as R3. Okay. So I'm telling you that these two circuits are equivalent. The star and delta and star are equivalent. Okay. But we don't know what is the relationship between RA, RB, RC, and R1, R2, R3. That we don't know. Okay. Then let us first find out what is the resistance between 1 and 2, terminals 1 and 2. If you see this circuit, what is the resistance between terminal 1 and 2? In delta circuit, what is the resistance between 1 and 2? That is RA. Okay. So this part, and this part are in parallel. So the resistance between 1 and 2 terminals, when you are considering this delta circuit, delta configuration, then it will be RA is in parallel to the series connection of RB plus RC. Let me know, is it clear or not? RA is parallel to RB plus RC. So you can write this. This will result into RA multiplied by RB plus RC, and in the denominator it will be some RA plus RB plus RC. Okay. Similarly, if you see this circuit, in this circuit, what is the resistance between 1 and 2 terminal? Here 3 is open. Here 3 was a closed circuit, so current will flow. But if you consider the star connection, here third terminal is open. If you connect the battery source here, let us say if you connect these two terminals in a like a circuit like this, and a source will be there, then current will flow through this path. No current will be flowing through this path because this third terminal is open. So if you want to find out what is the resistance between terminal 1 and 2, it will be, considering the star configuration, it will be simple R1 plus R2. Let me know if this is clear or not. For star and delta, I am trying to find what is the resistance between the two terminals 1 and 2. Now I am telling that these two are equivalent. To be equivalent, the resistance between the 1 and 2 terminals should be same for both the circuit. Okay, whatever be the internal configuration, whatever be the value of RA, RB, RC, or R1, R2, R3, this will remain same. The resistance between any two terminal will remain same. So due to that point, I can write that R1 plus R2, that should be equal to RA multiplied by RB plus RC divided by RA plus RB plus RC. So this is your equation 1. Similarly, for all other terminals, let us say the resistance between 1 and 3, let us say the resistance between terminal 1 and 3, between 1 and 3, what is the resistance considering delta configuration? RC is in parallel to RA and RB. So RC multiplied by RA plus RB divided by RA plus RB plus RC, and this should be equal to, if you consider 1 and 3 terminals in the star configuration, what will be the resistance between these two terminals? R2 plus R3. The second terminal is open. So the resistance between 1 and 3 terminal considering star configuration is R2 plus R3. Okay. Then again, this is a second equation, let us say. Third equation, resistance between second and third terminal. Between second and third terminal, this one. Okay. If you can remember the formula, no issue. For the basic subjects, remembering the formula will suffice the requirement. But when you have to do complex circuit analysis in your like advanced subjects, you are from electrical department. So in complex circuits, how to analyze that will be important. That's what I'm doing. That's why I'm doing this analysis here. So resistance between second and third terminal. That means RB is parallel to RA plus RC. So RB is parallel to RA plus RC. Okay, this will be equal to, again in this circuit, what is the resistance between 2 and 3? That is R1 plus R3. Okay, that is equal to R1 plus R3. Please let me know if you have any doubt in any of the step. Please let me know. I will stop and I will repeat. Okay, otherwise things will become more complex. Like here we want to solve maximum power transfer theorem, but to know that you have to apply Thevenin's. So if your concept of Thevenin's is not clear, then it will be difficult. Then again, to apply Thevenin's, here you can apply delta to star conversion. So delta to star, if its concept is not clear, it will be difficult to solve this problem. Number of equations will increase. Yeah. So main idea is to see this. This is like a delta conversion. If you remember the Greek words, then this is like a delta. This is a star-like symbol. Okay, that's why this configuration is known as delta. This is configuration is known as star. Okay. So what we are trying to learn here is how to, if one of the configuration is given to you, let us say in this circuit, we are trying to solve this circuit. Here we can clearly see that this is a delta configuration. If you see only this part, this is a delta configuration. If you see this part, this is a delta configuration. Definitely, you can consider this as a mesh. But for that, you will require two extra equations. So equations, multiple simultaneous equations, you know it is difficult to solve in time limited manner. So it's better to use, let us see, if you convert into star, whether things becomes easier or not. I already know that it will become easier. That's what we are doing. So that's why we are learning the delta star. But in practical cases, you have to just know that, okay, if I apply this star, then it will be easier. That's why I'm applying in practical cases. After your graduation, you can do that. Okay. Yeah. So star and delta and star. Okay, this is 1, 2, and 3. 3 nodes. 1, 2, and 3. 3 nodes. Here, the resistance between 1 and 2 is RA. Similarly, RB, RC. Here, R1, R2, R3 is there. Now, we are saying that these two are equivalent circuit. If these two are equivalent circuit, then the resistance between any two terminals, that will be same for both the circuits, irrespective of which circuit you consider, always the resistance will be same. Okay, that's what we are doing. We are first trying to find out what is the resistance between 1 and 2 using this delta configuration. This is delta configuration. This is star configuration. So in this delta configuration, what is the resistance between terminals 1 and 2? RA is there. And in parallel, this path is also there. RB and RC. So RA in parallel to RB and RC. Okay. So this is the resistance between terminals 1 and 2 if you see the delta configuration. If you consider the star configuration, then what is the resistance between 1 and 2? That will be simple R1 plus R2, because this R3 will not come into play because this is an open circuit. The third terminal is an open circuit. That means if you pass some current to this path, it will flow like this. No current will be flowing through this path because it's an open circuit. That's why the resistance between 1 and 2 terminal, this terminal is R1 plus R2. So since these two circuits or configurations are equivalent, that's why we can equate R1 plus R2 is equal to RA multiplied by RB plus RC divided by RA RB. Similarly, we are doing the same operation for terminals 1 and 3, terminals 2 and 3. For that, we have written. Now we have to simplify. That means, let us consider you have three equations and you have three unknowns. That is, what is the value of here in this problem? What is given? The delta configuration is given. So you can say that, okay, RA is equal to 15, RB is equal to 15, RC is also equal to 15. But you don't know what will be equal to what will be R1 plus R1, R2, R3. That you don't know. So from these equation, our aim is to find the values of R1, R2, R3 in terms of RA, RB, and RC. That is our main aim. So to solve this equation, let us say what you are doing, you are subtracting the second equation from 1. So let us say what you are doing 1 minus 2. You are doing 1 minus 2. So on this left hand side, it will be R1 plus R2 minus R2 minus R3. So R2, R2 will get cancelled. So you will get R1 minus R3. That will be equal to, on the right hand side, the denominator is for both the terms. So in the denominator, it will be RA plus RB RB plus RC. Okay. In the numerator, this will be subtracted from this. So RA B plus RA RC minus RC RA minus RC RB. Okay. That means this part we are subtracting from. So if you see, this will get cancelled. What you are left with? RA RB minus RC RB divided by RA plus RB plus RC. Now, so let us say this is equation 4. Now what we will do? We will add equation 4 with equation 3, because our aim is to remove this R3. Here it is R1 plus R3. Here it is R1 minus R3. To solve the value of R1, what you have to do? You have to add these two. So if you add equation 4 and 3, in the left hand, getting R1 plus R3 plus R1 minus R3. So R3 and R3 is getting cancelled. Twice of R1. In the right hand side, the denominator is same. That is RA plus RB plus, and in the numerator it is RBRA plus RC plus RARB minus RCRB. Okay, so this will get cancelled. Sorry, these two things will get cancelled. It is twice of R1, twice of RARB divided by RA plus RB plus RC. These two will cancel. Okay, what you are getting, R1 is equal to RA RB divided by RA plus RB plus RC. Okay, you have got the value of R1. Similarly, using same thing. So what is the, how to remember this thing? How to remember this thing? R1 you don't know. So this is R1, you don't know. So to find out R1, the equation what we got, R1 equal to RA RB divided by plus RB plus RC. Numerator you can always remember. Transforming from delta to star, the denominator will be the sum of the given values. Sum of the given values. That means RA plus RB plus RC. In the numerator, how to remember this thing? That means if this is R, like is like here. when you are trying to find out the value of this resistance, it will be the resistances in the numerator. It will be the product of the resistance that are on the both sides of this, Ra multiplied by Rb. If you want to find this resistance value, then in the numerator it will be Ra and Rc. Let us find. So if you want to find R2, if you try to find R2, how to find the value? You can solve all these things without solving all these things, just by seeing the similarity. Okay, R2 will be equal to, you have to come back to the delta configuration. R2 lies here, R2 lies here. On both sides of it, there is Ra and Rc. So in the numerator, it will be the product of Ra and Rc. And in the denominator, it will be sum of Ra plus Rb plus Rc. Similarly, for R3, similarly, for R3, it will be, for R3, it will be, you have to see that what are the resistances on the two sides of this R3. If you place this star inside this delta, then you can say that beside R3 resistance, it is Rb and Rc. So that you have to write in the numerator, it Rb Rc divided by Ra plus Rb plus Rc. Star to delta we will do, but before that, since we are learning maximum theorem, let us do the application. That means use the star to delta to star configuration to solve the given problem. Okay, let us do that. So remember this formula. Now let us go back to the problem. What was the problem for us? This one. Here, if you see this delta configuration, this circuit looks like this. Your circuit. Okay, I'm telling you that to transform this into delta star, what you have to do? You have to consider circuit like this. Okay, so this is 15, this is 15, this is 15. Now this R2 is unknown, this is unknown. So what will be R1? R1, you have to see what are the resistance beside these two. Just on the two sides of R1, there is 15, there is 15. So 15 multiplied by 15 divided by sum of all the resistances, 15 plus 15 plus 15. Okay. So here you will get R1 is equal to 5 ohm. Similarly here, R2 also you will get 5 ohm, because if you try to find out R2 using the formula, in the numerator it will be 15 multiplied by 15 divided by 5. And similarly, R3 will also be equal to ohm, since all the resistances are same. On the this part, everything is 27. Okay, this part is 27. So what you are getting? What is the delta configuration? Delta configurations look like this. So it is 27, it is 27, it is 27. And inside this, you are trying to find, okay, this is R1, this is R2, this is R3. So this is R1, this is R2, this is R3. Okay. So R1 will be equal to, beside R2 on both sides of R1, it is 27 multiplied by 27 divided by 3 times of 27. It will be 9 ohm. Similarly, R2 will also be 9, R3 will also be 9 ohm. Now let us simplify the circuit. Let us just replace this delta with star. Okay, let us replace this delta with star. That means it will look like this. Okay, and there will be this 100-volt battery here. It will look like this. Now things have becomes very easy. What you have to find? You have to find this plus minus VTH. If you didn't apply this delta to star configuration, then for each of the mesh you have to apply KVL and you have to solve multiple equations and do this. Means if you know this delta and star conversion, and again the formulas for that, it will be easy. Definitely, if you want to derive the delta to star, it will take much time. Now, what will be VTH? VTH will be the voltage across the open terminals. But some current is flowing, let us say here, due to this voltage source, some current is flowing. Will any current flow through this path? No, because there is this open circuit. So whatever current was flowing, that will flow through this path. So what is that value of the current? So I is equal to 100 divided by all the resistances. These are in series. This 5 ampere, this 5 ohm and this 9 ohm are of no use because no current is flowing through this path. So this 5 is in series with 5, that is 10, 10 plus 20, 30, 30 plus 9, 39. Okay. And again this 9. Okay. So you can find out what is the resistance value. So I is equal to V by R. V, the voltage you are applying 100 volt, and this is the current. Okay, so if you solve this, you will get the current of 0.2 ampere, 2.08 ampere. Now, what will be your VTH? Who will tell what will be this VTH? So this current I is flowing through this here. This I is flowing through this path. Then what will be your VTH? This VTH is nothing but the voltage across these 2 points. Because no current is flowing, there will be no voltage drop across this 5 ohm and 9 ohm. So whatever is the voltage here, that will be the same voltage you will get here. Okay, then what will be the voltage drop? The current flowing multiplied by these resistances. That means what is the voltage drop across this? Plus minus sign will be there, plus minus sign will be there, plus minus sign will be there. Okay, so I multiplied by 5 plus I multiplied by 20 plus I multiplied by 9. I, you know, 2.08. 2.08 you have already found, and you can add this 34 multiplied by 34. Okay, so if you do this, you will get some 70.72 volt. Now if you consider more like decimals after this, it will be 70.88. Okay, if you take more numbers after decimal, so it will get more accurate result. It will 70.88, I think. Okay, so 2.08 multiplied by 34, you will get this one. Okay, Arin, is it clear? I will share the notes. Which notes? Means I have already shared till. I have already shared, means theoretical questions. I have already shared the notes. Rajbir, if you see superposition, Norton's Thevenins, I have already shared the notes. Maximum power transfer I am doing today. Okay, I will share it. Yeah, this I will save and I will share. And then next is, so this is nothing but VTH. This is nothing but your VTH. Next is how to find RTH. So for finding RTH, what you have to do? What is the first step in doing RTH? You have to keep it open. But now you have to deactivate the source. So how will it look like? It will look like this. This is open circuit. So open circuit. There is this 5 ohm resistance. There is this 5 ohm resistance. 5, 20, 9, 9, 9, and then you have to short circuit this. Short circuiting this means, can we rewrite this as, this is 5, the short circuit, and there is this 9. Can we do like this? That means we are taking this here. Instead of like drawing this from outside, we are taking this just inside. So now you can see, if you have to look from these two terminals, what you are seeing, you are first facing the 5 ohm resistance. So 5 is in series with these two in parallel. These two are in parallel. So here it is 14. In this path, these two resistances you can add, it will be 14 multiplied by, what is the value of the resistance here on this path? That is 34. 14 plus 34. And then you have to add with 9. So this is nothing but your RTH. That if you find the answer, it will be equal to 23.92. Okay. Now the moment you have got VTH and RTH, so just draw the Thevenin's equivalent circuit, that is 70.88, let us say, or 70.72. The RTH, that is 23.92. RL you have to reconnect, you don't know its value. Okay, but from maximum power transfer theorem, you know that when RL is equal to 23.92, then you will get maximum power. You will get maximum power. So what will be its value? The maximum power transfer P max will be equal to the voltage that you are applying, that is 70.88. Okay, V square was there. So it was V square by 4 RL. Okay, it was V square by 4 RL. So V square you have found out 70.88 whole square divided by 4 multiplied by R, you have found it as 23.92 ohm. 23.92 ohm. So you can find what will be the P max value. So this is the first example of maximum power transfer theorem. Tomorrow we'll do the next part, that is how to apply maximum power transfer theorem when there is dependent source. Now to do that, you have to also solve Thevenin's theorem with dependent source. Ayush was asking the question that repeat what was done yesterday. So tomorrow we'll repeat that. Okay, don't miss tomorrow's class. We'll solve more examples on maximum power transfer theorem. Okay, let me save this and I will share this immediately. Let me save it. Save as, browse the downloads. It is class notes. And today's date is 4/9/20. I will upload it just now. Okay. Let me first take the attendance. You have your next class. Oh. The 19 students, first Korsame. Korsame is present. Aditya Raj. Yes?
Present, sir. Present, sir.
Yes, yes. I'm just seeing the participant list and I'm nothing. You don't have to. Then it is Akash. Akash Rai. Anag. Don't leave. I have not taken your attendance. Those names I am speaking, they can leave because I marked your attendance. Those names which I have not spoken, please don't leave. Anag. Then it is Apurva. Then Arin. Ayush. Ayush. Those who joined late, I will take an extra class on Sunday. When you will come here, I will take more extra classes. But till this part, I will take extra class on Sunday. It will start from 3, let us say. It will go on till your doubts are cleared. So it is Ayush. Then Charanjit is present. Devanshu. Devanshu is present. Korsame. Korsame given Nelson. Nelson is present. Pratik Raj. Pratik Raj. Pratik Raj. Then Rajveer. Rajveer. Sasikamal. Sivang Pal. Soham. Swastik. Yaswan. Okay. Okay, I'm marked your attendance. You can leave. Okay. Join your next class. Tomorrow we'll meet on 9. Sir, till which date the online classes will continue before offline? See, you will get the information. Definitely you will get 1 day time. Okay, I don't know exactly, but you will get the information. I think you have all got your academic calendar. Have you got your academic calendar?
Yes, sir.
Yes, sir, we have got our academic calendar.
So that information you will get very soon. Okay, till definitely you will get some time.
So what would be syllabus format, sir?
Miss.
Sir, is there any syllabus PDF that you have shared in the
I've
past?
already shared in Google Classroom. You can just see FE syllabus. You can download it. Yeah. Till what? Till the the full unit 1 and some definitely some part of unit 2. Okay. Consider unit 2, unit 1 and unit 2. Almost unit 2 you will cover. Yeah. You can download the syllabus from Google Classroom. Yeah, you can leave. If you have no doubts, you can leave. Join your next class.